Welcome back to episode 2 of our Unity RPG game development series. In this episode, we continue our journey towards building an immersive RPG experience. In the first part, we'll add the ground and create a visor for our capsule character. In the second part, we'll introduce 2 new states to our player character and implement a player state machine inherited from the state machine class we created in episode 1. Let's dive right in and bring our RPG game to life. To add a ground plane, we'll navigate to the Unity editor and follow these steps. Create a new game object by right-clicking in the hierarchy panel and selecting 3D object and then plane. By default, the ground plane might be located at different coordinates. To ensure consistency, let's set its position to 0, which is the origin of the world. With the ground plane selected, go to the inspector panel and adjust the scale to 50 to increase its size. This will make it more suitable for our RPG environment. By adding the ground plane and setting its origin to 0 and scaling to 50, we create a solid foundation for our RPG game. Now, let's move on to the next step and create a visor for our capsule character. This will allow us to see where the character is going when we move it. Now, let's move on to creating a visor for our capsule character. This visor will add a stylish touch to our character's appearance and contribute to the overall experience of our RPG. Select the capsule object in the hierarchy panel, right-click on the capsule object and go to 3D object, select cube. This will add the cube as a child object to the capsule. With the cube selected, adjust its scale in the inspector panel, set the scale to 0.5 on X, 0.2 on Y and 0.8 on Z to achieve the desired shape for the visor. Position the cube by setting its local position to 0.4 on X, 0.5 on Y and 0 on Z. This will place the visor at the appropriate position on the capsule. By following these instructions, we have successfully added a cube as a child object to the capsule and scale it to create the visor. The visor enhances the appearance of our capsule character and contributes to the overall visual appeal of our RPG game. In this step, we will create the PlayerStateMachine script, which will handle the state management for our player character. However, we will revisit this script a bit later when we create a player idle state. Let's get started. Right-click in the project panel, select Create and then C# script. Name the script PlayerStateMachine. Great. Let's make the necessary modifications to the PlayerStateMachine script. Remove the start and update methods as we do not need them at the moment. Next, we need to make the PlayerStateMachine class inherit from the StateMachine class we've done in the previous episode. The StateMachine class itself inherits from monobehavior methods. This inheritance allows us to utilize the core StateMachine functionalities and seamlessly integrate into our player character behavior. With the basic structure in place, we can proceed to add the player base state in the upcoming steps. Before we create our player base state, let's take a moment to organize our project structure. It's always a good practice to keep our codebase clean and easily manageable. We will create a dedicated folder called State Machines within our Scripts folder. This will ensure all our state-related scripts are neatly organized. In the project panel, find and select the Scripts folder, right-click inside the Scripts folder and choose Create Folder from the context menu. Name the new folder State Machine. This will serve as a dedicated location for storing all our state-related scripts, including player base state. Let's create a new script inside the State Machine folder and call it player base state. Now, we have created the player base state script, which will serve as the base class for implementing specific states for our player character. Now that we have our script ready, we can make our player base state class abstract, which inherits from the state class. Player base state will serve as the base for implementing specific states for our player character. Then, we define a protected member variable called PlayerStateMachine of type PlayerStateMachine. This variable will hold a reference to the PlayerStateMachine instance associated with the state. Next, we create a constructor for the player base state class, which takes a PlayerStateMachine parameter. This constructor allows us to set the PlayerStateMachine variable when creating an instance of the specific player state. By implementing player base state, we establish a solid foundation for creating and managing different states for our player character. This design pattern enables us to define unique behaviors and interactions for our players. Great, let's go back into Unity and create our first state of the player idle state. Let's right click in the project panel, go to create and create a new C# script. Let's call it player idle state. Open the player idle state script and let's go back in VS Code. First things first, let's remove the start and the update function and make the player idle state inherit from the player base state class. Player idle state represents the idle behavior of our player character. We then define the constructor for the player idle state class, which takes a PlayerStateMachine parameter and passes into the base class constructor using the base keyword. Next, we need to override the enter method from the base class. This method is called when the player enters the idle state. For now, let's just simply log a debug message to indicate that the player has entered the idle state. We also need to override the exit method as well as the update logic. So the exit method is called when the player exits the idle state. Since there is no specific functionality to be executed on exit in this case, the method is left empty. In the future videos, we will probably use the exit method to stop the animation for the idle state. Finally, we have the update logic method from the base class. We need to override this one as well. This is called during the update loop and is responsible for handling the logic specific to the idle state. For now, let's just log a debug message to indicate that the logic is being updated. Before we go and test the player idle state, we need to do some modifications to the PlayerStateMachine. So let's go back into the PlayerStateMachine code and see what we need to do. To ensure a smooth startup for our PlayerStateMachine, we will add a private startup method. This method will be called automatically when the PlayerStateMachine starts up. Within the PlayerStateMachine class, let's add a start method. This method is automatically called when the PlayerStateMachine starts up. Let's now introduce a private method called initializeStateMachine. This method serves as the startup routine for our PlayerStateMachine. By calling this method in the start function, we ensure that the PlayerStateMachine is properly initialized. Inside initializeState method, we use the changeState method to update the initial state to the player idle state by passing in a new instance of the player idle state and providing the reference to the current PlayerStateMachine, in this case this. We set the initial state to the player idle state. Great, we've made all these changes. Now it's time for a bit of testing. Let's go back into Unity. Before we hit play and test our code, let's remove the state machine from the player capsule that we've added in the previous video. Now we need to substitute that with the PlayerStateMachine that we've created now. Now that we have made the necessary modifications to our player capsule, we are ready to test the changes. When we click play, we will observe two types of console messages. The first message, enter the idle state, is logged only once. This message confirms that the player has successfully entered the idle state when the game starts. The second message, which is continuously logged in the console, is the result of the update logic method in player idle state. This method is responsible for updating the logic of the idle state continuously while the game is running. It demonstrates that the logic is being updated and executed as expected. In this episode, we've made significant progress in our RPG game development journey. We added the ground, created a visual appealing visor for our capsule character, and introduced two new states using the PlayerStateMachine. Stay tuned for the next episode where we'll continue expanding our RPG world and implementing even more exciting features. Don't forget to subscribe to our channel to receive updates and never miss an episode. Happy game development!